All right, so this is a review of the difference between XYZ space, UVW space. So the first thing that I'm going to do is I'm going to make an array of points. And just to be completely explicit about everything. Right, sometimes when something's a constant, I'll just name it the value. So let's call that 0, both in name and the value that it holds. We'll do the same with this, or 1. So now I have this this domain that goes from 0 to 1. And I'm going to use that domain to feed a range. And this is going to tell me how many, let's call it the number of X vowels. Oops. Say somewhere between 1 and 50. And if I hook that up to my range, all right, now I want to do the trick that I learned from Jason. I say n minus 1, right? Because if you take this domain and you divide it up 2 times, chop chop, you get 3 values, and what we really want is 2 values. All right. So now as I slide this, I get 25 values going from 0 to 1. I can copy this part of the definition because I want that same domain, but this will be my number of y values. And I can hook x up to x, y up to y. Oops. X up to x and y up to y. And what I really want is to cross-reference them. All right, so I have a grid of points. There are easier ways to create a grid of points. There's just grid, but I don't know. This is how I've always done it, and it's instructive to do it this way, so there you go. All right, and this point down here, let me change the preview so we can see what we're doing. All right. So this point down here in the world is at 0, 0. And up here, this point is at 1, 1. Right? I'm going to go ahead and save. Twenty-three. So now, at the same time, the other thing I did last time is I developed a surface. And the thesis is that surface, even though that surface exists in the XYZ world, can be thought of as defining its own space of U and V, the space of that surface. In other words, if you think about this room, right, we exist on the Earth. There's longitude and latitude that defines where we are. We could fix points that define, the corners of this table on the Earth. But at the same time, we could also say, all right, this pin is now located, 3 feet from that corner in X, and 2 feet from that corner in Y, and that's not the X and Y of the Earth or Newark or New Jersey, it's the X and Y that's relative to this table. And when we're talking about a relative coordinate system as opposed to a global coordinate system, instead of X and Y, we say U and V. And instead of Z, we say W. So if I were to take this pin off the surface of the table, and hold it 1 foot in the air, it may be like 4 feet off the ground, but it's 1 foot off the table. It's like 4 feet in Z, 1 foot in W, relative to this table. So the way I did this for you last time was I set up a point. And I call that the origin. And an x vector. We'll call this width. Maybe hook up a slider. And transform that point. We'll call that x end. Maybe copy this down, copy that down, and do the same for y. We'll call it depth. We'll call that y end. Right. This should look, familiar. And I'm going to make a line. So this is my x-axis. My y-axis. Right, and I'm going to reparameterize them. Right, which is a way of explicitly setting the domain of that line to go from 0 to 1. When I say 0, I mean the beginning. When I say 1, I mean the end. That's what reparameterize means. Right. And then I said, okay, we want to take a parameter and make it this sort of, the intermediate point. So we can take a slider that goes from 0 to 1, and we can evaluate that curve. Evaluate curve. Right? So t is always lowercase t is always how it talks about a parameter on a curve, right? From 0 to 1. And we can do the same down here for our y-axis. Right? And that, so 0 to 1 describes its distance along this path, but then what we get out of that is an actual point. And that point, we are going to then move up or down. So I'm going to take this slider and make it go from -100 to 100. And we're going to say x-axis z shift. And I'll make another vector, and I will use that to transform this point, right? I guess that's the y-axis z shift, huh? Okay. All right, so it's that point. Move it according to this vector. Right. So when we look at it over here, you know, this slider controls that distance, and this slider controls where it is along that line. And we can call this our intermediate point. You know, and then if I wanted to, what I could do is I could make a point parameter that says, and I could dump in my origin in this order, the origin, right? Then hold down Shift, the intermediate point, and then hold down Shift and the Y end, right? So now I have a list of 3 points. And I could use that list of 3 points and interpolate it to make a new curve. All right, so I now have a parametrically controlled curve on the y-axis. All right. Now I'm going to copy this logic up. But over here, I'm going to use my point on the x-axis. So this is now my shift along the x-axis. And I'll do the same thing over here, where I get a point parameter and hook up my origin, my intermediate point in x, and my x endpoint, right, in that order, and then do an interpolate curve. Now, you know, while we're at it, right? So this is it's my x-axis. Let's do this. Let's go back to the y that was over here, right? So this slider controls where my intermediate point is in y, and I'm going to copy this. So I get another point, second point. And I'm going to take that point and I'm going to go back up here. This is the transform that transformed my origin and moved it along to create the x-axis. And I'm just going to copy that move. And then I'm going to move that point over. Right, so now I'm creating this is controlling a sort of intermediate point on the other side. And then I'm going to copy this shift here and use it to move that point up or down. Right, so now I'm basically making a new intermediate point on the other side. Right, and this one is the one that moved my geometry all the way over in x. I'm going to do the same with the y end. I'm just going to copy that parameter so that I have some hope of reading what's going on here later. So I'm going to call that y end 2, and I'm going to call this guy sort of intermediate point y2, and make another point parameter, and this time I want to hook up, where is it? You know, I really should have been a little bit more organized about this. My x end my second y end, oops, and my second intermediate y, and then my second y end. So now I have 3 points over here. Right, and I can create another line. All right, so here I have, let me dump these into some parameters. This is our sort of x curve. Y curve 1. And Y curve 2. And so to make a surface out of this, I could do it in two ways. I could do one sweep, where I say the rail curve is this one. And then the section curves, so if I do that, right, it's just going to sweep this curve across that rail. But if I hold down Shift and add this guy, now it's using this as a second section curve to interpolate. Right, so now I have this kind of fully parametric surface where I can control the section on one end, you know, including like where that point is, right, and whether it dips up or down. I can control the section on the start end the same way, and I can control the section in X, you know, similarly, right? And of course, if I wanted to, I could do the same thing over here, where I make another curve. Or I could make multiple intermediate curves if I wanted to. Like I could have 3 sections or 8 sections or whatever. So I don't know if you use these things, but they do tend to help you make things neater. All right. So there's my surface. It's also, and I've hinted at this before, I really like being able to take all of my parameters that are inputs and kind of put them all on one side and line them up. You know, so this is the stuff that controls the Y curves. You know, here's the stuff that controls the Z curves, or sorry, the X curves, excuse me. I'm going to hit save. This is the overall width and depth of the surface. You know, and here's the origin point. And I could group all this, turn its preview off. Okay. So you're all with me. The reason why I build this up in this way is that it should be really apparent that because, let's see, right here, right, here's my x curve. I'm going to turn its preview on, right there. That I can evaluate the curve just like I did before, between 0 and 1, and you get a point that can travel along that curve. And I can do the same thing to my two y curves. Right? They're just curves. There's nothing special about them. Right? I can evaluate it. Oops, I didn't reparameterize. Right? Unless you reparameterize it, you don't know for a fact. Like, sometimes the curve domain is different depending upon how the curve has been created. Right? But if you reparameterize it, it always goes from 0 to 1. Right? So now you can see, like, that's 1 on both those curves, that's 0 on both those curves. And you could see that this one, right, because it's not as curvy, doesn't have that extreme dip in it like this one does, it's actually a much shorter curve, right? So when I move this back and forth, that point travels faster. Whereas curve 2, it's physically longer in the XYZ world in which we live in. So that travels slower. Right. And so for both these, the curves here and the curves here, they go from 0 to 1. They can be thought of as a kind of one-dimensional object, right? They have a start and end place in between. And so when we talk about this idea of UV coordinates, you could see how if I take the this parameter along the y-axis, and it's just a number, but I'm going to use it to make a point. I mean, physically make a point, not like. And the same with the x, right? So what I get now is I get this point that has coordinates in x, XYZ space, right? Over here. When I move this around, right, or I move this around, this component over here, which is taking those numbers, is generating a point that we can think of as existing in the world in XYZ, and it does exist. But we can also use that point as the input to an evaluate surface command. To do that, we need to reparameterize the surface just like we reparameterize a curve. And then we give it UV coordinates in the form of a point. So here, what it's saying is, like, I know that this is XYZ, but I want to interpret it as UV. And so when you do that, right, you're now mapping, right? So that's in x going from 0 to 1. And this is y. And you can see that not only are you getting a point as a result of this evaluate surface, but it's also giving you a plane, which is the plane that's tangent to the surface at that point, and a normal vector, which is the vector that points up. So for example, you could take that vector, you could do anything with it. You could, if we say adjust its amplitude, we take that normal vector, and we make the amplitude, I don't know, something between 0 and 100. Right? This amplitude component just says, you give me a vector that's pointing in some direction, I'm going to change its amplitude. So by default, most vectors, if it's giving you a normal vector to a surface, usually the amplitude is 1. And maybe we want to make it, 30 or whatever. So that then when we use it to transform this point, and then we use that to draw a line. Right, so you can see what that's doing now. I turn down the amplitude. Right, and if you look at this in, let's say, elevation, it's easy to see that as I travel along the surface, that line, which is always pointing parallel to the surface, is, pointing in strange ways. So you're all with me, right? All right, cool. So what this means is, like anything in Grasshopper, if you can do it one time, usually, you could do it a whole mess of times. So over here, right, we produced a grid of points in X, Y, Z space. There's nothing stopping us from, instead of using my slider or my sliders to make a point along that surface to evaluate the surface at, I could just hook up my grid. And so if I do that, let me turn it off. So, now what we have is like a whole bunch of a whole bunch of points. Let's make this a little bit shorter. Right. So here now we have a field of points which has been mapped from XYZ space into UVW space. And they're mapping along that surface. Right? And because the surface has been made with these curves that are moving, that are curved in Z, the surface is deforming, and the normal vectors are pointing, in all sorts of ways, which is why you get that.
As I travel up these lines pointing away from the surface, that's like moving in W's? In W
yes,
direction?
Exactly. That is moving in W. So as a result, right, what you get, if we were to do something like, turn the surface off and turn these lines off, and just look at this in a top view. And maybe over here, amp up the number of values. I'm going to hit save. This is a good thing to say to yourself, is anytime you're narrating what you're doing and what you're about to do is, quote, amp up the number of values, you should save. So we amp up the number of values, right? Well, that's kind of cool looking. Let me just move the
say the name of that phenomenon was? Like the emergent patterns aren't really there, just because the pixel size is too
Aliasing?
aliasing. Yeah.
I'm gonna change my slider to be go from 0 to 20 and allow decimal values, right? So here, this is what happens when I'm just changing now the length of the z vectors. Right, and so you get these kind of like hair-like artifacts. You know, and if you wanted to, you could, I don't know, we could put balls on the end of them. It always looks good. Whoa. I think the radius for this is going to want to be very small. Right. So there we have a kind of, parametric surface field, where we've mapped the UV coordinates onto this warped surface. So in X, Y, Z world, right, these points are just a sort of very dumb grid, right? They're evenly spaced. But when we map them onto a surface, it's like, what it's like? This is exactly, I think I mentioned this last class, it's exactly like silly putty, which I don't know if that means anything to you, but, but when newspapers were printed on paper, you could take your silly putty and, like, smack it down on, like, the comics, and then you'd get the image because the ink would rub off in the silly putty, and then you could stretch it. And that's what we're doing here. So what would be sort of interesting is you'll see, like, if we start to move these, well, so I guess not really able to update in real time. If I turn the spheres off, maybe. If I turn the spheres off, as we, as we update the curves that change the surface, you get different sort of effects in the way the spikies spike. I don't know. So one last thing, right? So here, right, I get a list of 2,500 normal vectors. And here, I'm making them all have an amplitude of 5.456. If we wanted to, we could do something like this. We could set up a domain from some small number to some other small number, right? 2.13 to 5.4. And then say, give me a random value in that domain. How many of them? The easiest way is to say, what is the list length of my normals? Right, so that says, I take a list, I hook it up, it says, okay, there are 2,500 values, so fine, I want 2,500 random numbers. And then I could use that to hook up to my amplitude. So now my spikes are all different different sizes. But I can adjust the range in which they fall, right? I can make them all close to the same size. I can make them wildly different. I'm showing you all my tricks. We could do the same with the sphere radius. Go from something very small to something pretty small. What's my problem? Alright, so there, now I have I don't know, it just got a little weird. It's like a chia pet. I made a parametric chia pet for you. Yeah.
He's so sweet.
Yeah. Spread the chia seeds, fill it with water, hook up your parameters, and watch it grow. I'm going to stop this for
I'll
now.
show you in Grasshopper.